So in this question, we're told that the function g is defined as follows. So we have that g of x is equal to 3 ln x minus 7 divided by ln of x minus 2. And we're told two key pieces of information, that x is greater than 0 and that x is not equal to k, where k is a constant. So in part A of this question, we're asked to deduce the value of k. So we need to have a think, what cannot k be? So we know that when we have a fraction, the denominator cannot equal 0. So therefore what this means is our denominator cannot equal 0 either. So from this we can work out what value x cannot be for the denominator to not be 0. So therefore, to do this, we'll say ln of x minus 2, we'll set that equal to 0, and we want to solve this, so we want to rearrange this so we find x. So therefore, we can add 2 to both sides, so we'll have that ln x is equal to 2, and then we want to isolate this value of x here. So we can do that by taking the exponential of both sides. So we take the exponential of ln of x, and we take the exponential of 2. And then therefore, this cancels out here on the left-hand side, so we'll have that x is going to be equal to e of 2. So therefore, from here, we can say that the value of k is going to be equal to e to the power of 2. Or another way we could write this, we could write it in the form we're given here, x is not equal to e2. So therefore, we have achieved 1 mark here for concluding with the correct answer, and that was that k was equal to e to the 2. So in this question, we're asked to prove that g dash of x, so the derivative of the function g, is greater than 0. And we're asked to do this for all values of x in the domain of g. So an important part of this question is going to be the quotient rule. So if we have a function where we have a fraction, so we have f of x as our numerator and h of x as our denominator, then we can say that the derivative of this, so g dash x, is going to be equal to the derivative of the numerator multiplied by the denominator, and then we'll subtract the numerator of g of x and multiply it by the derivative of the denominator, and then we divide all of this by h of x, which is our denominator of the original function g of x. So what we're going to do is we're going to recall that from part A of the question, we have what we're given. So we're told that g of x was equal to 3 ln of x minus 7, and we divide this by ln x minus 2. So therefore, we're going to let f of x equal our numerator. So we have that f of x is equal to 3 ln x minus 7. And likewise, we're going to say that h of x is going to be equal to ln of x minus 2. And then what we're going to do next is we're going to differentiate both of these. So we'll have that f dash x is going to be, so how do we differentiate ln x? So we have that ln x is going to differentiate to 1 over x. So therefore here, it is going to differentiate to 3 over x. And likewise for h of x, we'll have that the derivative of h of x is going to be equal to ln x, differentiate that, that's going to be 1 over x, and again our constant value differentiates to nothing. So the next stage is going to be to take these values and plug them into this formula here. So therefore, what we can say that g dash x, so the derivative of g of x, is going to be equal to, so we'll take f dash x, so we'll have 3 over x, and we're going to multiply that by h of x, which is ln of x minus 2, and then we're going to subtract the derivative of h, that's going to be 1 over x, and we're going to multiply that by f of x, which is 3 ln of x minus 7. Then we need to remember and divide all of this by h of x squared, which is going to be ln of x minus 2, and we add in our squared term there. So now we're going to look to simplify this slightly. So we'll just expand the brackets out, and we'll have 3 over x multiplied by ln of x. Then we're going to subtract 3 over x multiplied by negative 2, which is going to be 6 over x. And then we'll subtract 1 over x multiplied by 3 ln x, so that's going to be 3 ln x. And then we're going to divide that by x. and then we multiply negative 1 over x by negative 7, so we have a positive 7 over x. Then we got to remember and divide this all by our denominator, which is ln x minus 2 all squared. So we're then going to slightly simplify this. We can see that we have 3 ln x over x and negative 3 ln x over x, so they cancel out. And then we have 7 over x minus 6 over x, as you can see here and here. So that leaves us with 1 over x. So therefore we have 1 over x, and then our denominator stays the same. It's ln x minus 2, and we square that. So then we can therefore simplify this further by bringing this x term here down into the denominator. So therefore we can conclude that the derivative of g of x, g dash x, is going to be equal to 1, and we're going to divide that by x, and we're going to multiply that by ln x minus 2 all squared. So we look back to the question, and we were asked to prove that g dash x was greater than 0 for all values of x in the domain of g. So we notice two things here. So we know that x is always greater than 0, and then we also know that our other term is squared. So we have that ln x minus 2 is squared. So therefore from this we can conclude that the denominator is always positive, and thus g dash x will always be positive. And therefore we've completed this question. So there was 3 marks on offer, and we receive our first mark for attempting to differentiate using the quotient rule. So we'll give ourselves the first mark at this stage here. We then receive the second mark for differentiating correctly, and we then receive the third and final mark for having this concluding statement about why the derivative of g of x is always positive, and therefore we've completed this question. So here in this question, we're asked to find the range of values of a for which we have that g of a is greater than 0. So we recall from the previous parts of the question that we are given that the function g of x is equal to 3 ln x minus 7 divided by ln x minus 2. So what we're going to do is we're going to solve this and make it like an inequality to be able to deduce the values of a of which g of a is greater than 0. So what we're going to do first is we're going to let ln of x equal y, and this will make things slightly more straightforward to begin with. So then we have that g of x is going to be equal to 3y minus 7, and then we divide that by y minus 2, and we know that this is going to be greater than or equal to 0. And this is now the inequality that we want to work with. So firstly, if we multiply both sides by y minus 2, so this means that the denominator will disappear or effectively turn to 1 on the left hand side, and we multiply y minus 2 by 0 on the right hand side, so therefore that is equal to 0. So therefore we have that 3y minus 7 is greater than 0. So we can now rearrange this and solve for y. So we'll add 7 to both sides, which leaves us with 3y is greater than 7. And then we can divide by 3 to give us the fact that y is going to be greater than 7 over 3. So therefore we replace y with ln of x. So we can say that ln of x is greater than 7 over 3. And now we want to work in terms of a. So I'll just write in brackets, we change x to a. So what we can do now is we can take the exponentials of both sides, which is going to leave us with a is going to be greater than e to the power of 7 over 3. And secondly, we notice that we have y minus 2 as our denominator. So we know that if y is equal to 2, then g of x is not going to be defined because the denominator is equal to 0. So therefore, what we can say now is that for this whole function to work, we must have that y is going to be less than or equal to 2, which therefore means that ln of a, so we'll just put a in straight away this time, that is going to have to be less than 2. So therefore, taking exponentials, we have that a must be less than e to the power of 2. We also know that our value of a, so we're told in the first part of the question that x is greater than 0. So since effectively a is now x, this means that we know that a is going to be greater than 0. So this means that this value of a must be between 0 and e to the power of 2. So we can therefore write that 0 is less than a, which is less than e2, and we can also take in our result from above, and we also have that a is going to be greater than e to the power of 7 over 3. And therefore, we have shown the range of values for which g of a is greater than 0, and we've completed this question. So there was 2 marks available in this question, and we achieved our first mark for attempting to solve this using inequalities. So that was at this stage here where we started showing our use of inequalities. And we then received our second mark for concluding with the correct answer, which was that firstly, a is between 0 and e to the power of 2, and secondly, that a is greater than e to the power of 7 over 3. And therefore, we've completed this question.